A 3 by 3 system of equations. So we've got 3 equations and 3 variables. We could use substitution or elimination method, or a combination of those two. If it's later in the semester in intermediate algebra, you could use Cramer's rule or matrices in some way. But since I'm sort of at the beginning of reviewing intermediate algebra, I'm going to use substitution and elimination. So what I like to do is label the equations, like this is equation A, B, and C. And then let's see, what could I get rid of? I think the y's are a good candidate, because if I just add these two equations, that's going to eliminate the y's. So that's equation A plus B. So this is just so that I can follow my own work, and when my students do it, then I can follow their work, see what they did. Equation A plus B. So that means you add these two together, so that's 3x. You add these two together, that gets rid of the y's, that was the point of the whole thing. Add these two together, that's going to be plus 3z. And then, nice and simple, equals 0. If I go back and get another two equations, like B and C, if I add them together, then these y's are going to cancel as well. So then, if I add equation B with C, then the result is 5x's. The y's cancel, and that would just be 1z. And left over here would be a positive 4. I could then use either substitution or elimination on these two equations. So now I've taken a more complicated situation of 3 variables and 3 equations and brought it down to just 2 variables and 2 equations. So now I think that I'm going to go ahead and right here solve for z. So subtract 5x from both sides on that equation and then substitute. So then you substitute this into this top equation over here. So this z right here gets replaced with the 4 minus 5x. So it would look like 3x plus 3 and then 4 minus 5x equals 0. So now we've got it down to just one equation and one variable. So you take it from the more complicated to the simpler to the more simpler. Now to solve for x, I need to distribute the 3, so this is going to be 12, and this is going to be minus 15x. And then still equals the 0. So combining the x's, that's going to be negative 12x. And then I could take this 12, move it to the other side, or in other words, subtract 12 from both sides. And then when you divide, it's going to be negative 12 divided by negative 12, so x is a 1. I'll just circle it so I can keep track of my work. Alright, now that we've got x, you can go back to this equation right here, substitute what x is equal to, and we'll have z. So z is going to be 4 minus 5 times x is a 1. And so z is 4 minus 5, z is equal to negative 1. Now that we have those two, then go back to one of the original equations, whichever you want to work with. I'll use the top one. And substitute what we got for x and what we got for z, a negative 1. And equation A says it equals 2. Oh, nice. So the 1 and negative 1 are going to cancel each other out. Our work is done. Y is equal to 2. Now, one last thing is, because this is a point in space where these 3 planes are crossing, imagine like 3 pieces of paper, they're crossing and hitting in one point. Well, that one point is where x equals 1, y is equal to 2, and z is equal to negative 1. So really the answer is supposed to look like that.